Okay, so the next one will be the application of our total internal reflection, which is the optical fiber. So what are optical fibers? Optical fibers are long and thin flexible tubes. Yeah, so they are made up of two materials. One is of course your more dense material, then the other will be known as the less dense material. So there are two parts to optical fiber. So inside is what we call the core. So this is where your information or your light will travel. Then the outside or the outer layer is called a cladding. So the core must have a higher refractive index, whereas the cladding must have a lower refractive index because you want total internal reflection to occur. That's why you must fulfill the so-called first criteria. Okay, so what is the purpose of your optical fiber? So the purpose of optical fiber is actually to transmit light or even information over a long distance. So of course the next thing is optical fiber are rapidly replacing copper wires in telecommunication and computer network. Another application of our optical fiber is actually used in the medical field. So I believe you have heard of something called the endoscopy. So endoscopy is used to check the inner layer of your large intestine to check any maybe any cancerous cells in the large intestine. So you can also use an optical fiber in this particular context. Okay, so first thing, let's take a look at what are some of the advantages of your optical fiber. So the very first is that the speed of data, right, of transmission is much faster in your optical fiber compared to your copper wire. So that's the very first one. Okay, then the second is the data transmission is not affected by E field and magnetic field. Third will be that the bandwidth and capacity for data is much greater. Number fourth will be that optical fibers are not affected by corrosion unlike our copper wires. And the fifth will be that there will be less signal loss in the optical fiber. Alright, so okay, so maybe I go back to the picture right here. So just take note that since the core has a higher refractive index, means that the speed of light inside the core must be lesser. So means that the speed is less. So you will not travel at 3 times 10 to the power of 8 meter per second. Alright, so that is the main idea of your optical fiber. Okay, so let's move on to the trial itself 3, which is 2021 combined science physics. So we have this light from lamp passing through the transparent disc and enter the bundle of your optical fiber as shown in figure 12.3. So notice one thing is that optical fiber B is bent but not broken. The critical angle for light in the material of the optical fiber is 38. What is the refractive index of the material of the optical fiber? So this one you just simply use sine C equal to 1 over n. So what is C? C is 38 degree. So you manipulate, you should get 1 over sine 38 degree. So since you have 1 divided by sine 38, you should get a refractive index of 1.62. So that is for part I. Okay, part 2, by reference to figure 12.3, explain why light leaving optical A is much better than that leaving optical fiber B. Okay, so you look at A first. A, there's no bending, so means that okay, for example, my light I extend a bit, my light will hit at this surface. So this angle actually is rather big. Okay, so high chance that the angle of incidence here will be greater than the critical angle. Okay, the next thing is I look at optical fiber B. Optical fiber B is bent at this particular location here. So of course I draw. So you can see that the light actually has a very small angle of incidence. So there is a possibility that the light will escape because you are less than the critical angle, or you are equal to the critical angle. But in this, for simple analysis, right, we take it that the angle of incidence is less than the critical angle. So you will escape into the air like this. So if there's a there's a detector here, a light detector, right? So less light will be received by the detector in optical fiber B compared to A. So A, right, I have a detector here, so the light will undergo total internal reflection because the angle of incidence is so much greater than the critical angle. Okay, so that's how we explain. So 3 marks. So first you talk about A, optical fiber A. The light has a large angle of incidence. Hence, there is a higher possibility that the angle of incidence is greater than critical angle. So if it's greater than critical angle, this will cause total internal reflection to occur. Okay, now we go to point number 2. Point number 2, we talk about optical B. Okay, optical B, light, because of the bending, so because of bending of optical B, right? So the light actually has a smaller angle of incidence. So this so in the event that the angle of incidence is less than the critical angle, right, light will escape the optical fiber into the air. So of course the third point just conclude. So less amount of light will be received in optical B. So that's how we explain this part 2.